Welcome to MMT Chats. This episode brought to you by ISCAR with new ideas for machining intelligently. Hey MMT followers, Christina Fuges with MoldMaking Technology back for another quick MMT chat. My guest today is Jordan Robertson, who is VP of Business Development and Marketing at StackTeck out in Ontario, Canada. Now, before we get started, I want to tell everybody out there, don't forget to like and share the video. Subscribe to MMT's YouTube channel and hit the bell to get alerts when new videos are available. All right. Hello, Jordan. How are you?
Hi, Christina. I'm great. How are you?
Not too bad. All right. So MMT, we've covered StackTeck a lot over the years. And I guess a while ago, you were even a lead time leader or awards competition honoree. StackTeck is twice. That's right. StackTeck is a global manufacturer of multi-cavity, high-volume production molds. And to me, it's known for a lot of mold technologies to improve efficiencies, lightweighting, and automation in caps and closures, thin wall packaging, medical, the PET preforms. But I know there's more. So why don't you give our viewers a snapshot, if they don't already know, of who StackTeck is?
Absolutely. Thank you, Christina. Thank you for this opportunity. The primary business of StackTeck is high technology injection molds, specializing in packaging and medical. That history goes back for 50 years. And we are building many of the industry leading technologies with respect to many things like running the fastest possible cycle time or making the thinnest, lightest possible part. In more recent years, we have opened a new automation business starting in 2019. And at the same time, we have entered a new market space area for PET preforms, building big high cavitation molds for that. So that's been an expansion of what we do as a company. But ultimately, we're looking to be everybody's logical choice for injection molding solutions.
Oh, I like that. Everybody's logical choice. That's a good tagline.
Thank you. It's actually pretty close to our vision statement, global partner of choice for injection molding solutions.
I like that. All right. So you've been with StackTeck for 21 years in this role, correct?
In this and similar roles, I joined as general sales manager, heading up the sales and service functions for my first few years. Then I moved into business development and added marketing as I went.
Okay. All right. So what would you say in that time span, what has been the biggest change at StackTeck?
So that one's easy because the bulk of what we do is mold making, and that's been an evolving progression of what we do. The biggest change, of course, is adding a whole new product in automation where there are different expectations. It's a brand new facility, new team, new requirements. And of course, it works very well that most of our automation is built to go with our mold. So it's a customer we already know, it's an application we already know, but that's certainly the biggest change that we've had in our history here.
All right. Does that tie nicely into the biggest challenge?
It does for sure. Because when you're building and starting and creating something out of nothing, I would say that has been the biggest challenge, where you got a new team, a new facility, you're geared up, and you're looking to get moving as a business. And at the very beginning, that's a challenge, just to get customers comfortable with embracing you in a market that is mature. There are existing high technology automation providers available on a global basis, and we were new starting in 2019. I'm very pleased to tell you that in 2022, our sales targets for automation were exceeded by 200%. So now we've gone from how do we get started to holy cow, how do we expand the team fast enough to keep up with the order intake? So that's a fabulous.
Wow.
But the toughest challenge was just building that initial momentum.
Yeah, it's funny that toughest challenge then leads into the next challenge of a good challenge, right? Of having to expand and find people. That's great.
Yes, absolutely.
All right. So what you have done, you have worked on so many interesting and innovative concepts at StackTeck. So what is your most notable project?
Well, I think the most notable thing that StackTeck has done, and there are many of them, in ultra lightweight, we do things that lead the world and the industry. In stack mold technology, we do things that have led the world. But to me, the most important one has been CoolTrack, and just taking the guts of the mold design and making it perform better with superior cooling, superior ejection movements. And so CoolTrack starts at the design phase. How do you take what was the standard and create the new standard and assess, I think this is better. How do I know it's better? So a lot of engineering tools, a lot of prototyping to empirically prove out those engineering tools and figure out what are the settings supposed to be in those software packages, and then delivering with a range of materials and special materials that transfer heat faster while maintaining the toughness of H13, to deliver conformal cooling, to take advantage of when we think of the most advanced cooling, we're typically thinking of either diffusion bonding components together or additive manufacturing of steel, or sometimes brazing and some other things are putting in inserts. And that's an area where there actually is a lot of development. We are very much in early stages of harnessing all those technologies and figuring out what's the best way to put them all together in the latest and greatest mold when a customer says they really want to run as fast as they can. And I think that's the most exciting challenge, because you take the value of the mold and you multiply it with all the speed you can put in there to cool faster.
That's going to be fun to watch you guys conquer that.
Well, we're getting faster and faster. Sometimes we just have to shake our heads how much faster we were going than we were 5 years ago, or
yeah, it's crazy.
10 years ago. It's tough keeping up sometimes.
It is. All right. So this is a good segue right into all the different innovations. Why I think it'll be easiest just to review and run down a list. So why don't you walk me through a few of the key areas, and why don't we start with automation? Tell us what's going on at StackTeck.
Absolutely. So like I said, it's a young team and we have a fairly narrow product range at this point. We build robots for in-mold labeling and for straight takeout at the accompanying speeds. And the systems we're building to date are for machines in the size range of from 250 ton to 600 ton or 650. That's basically what we're building. And of course, we get asked to quote some bigger things, some different things, and so on. And right now we're staying within that envelope because we're extremely busy delivering. And I'm sure long-term we will expand the size of the envelope, but for now, that's where our focus is at.
All right. How about the collapsing core technology?
So collapsing core has been a technology we've used for many years. We were already doing that when I joined StackTeck 21 years ago, and we were building molds up to 32 cavities with that technology. With a 5-piece collapsing core, we can release an undercut around the full perimeter of the part with all water-cooled core components. And we've recently enhanced our design to allow for greater flexibility in the part design and larger undercuts. One example is, I'll pull off my desk here. This is a paint can that is produced by KW Container. We're very thankful to them for letting us do a press release last year showing that where they used to make this can out of one straight can and then bond a ring on top, they haven't had to change their part design. We have a very significant undercut on all the way around the side of this, and they're now molding it in one piece on and that opens up the door to new applications. They were able to, they didn't change the lid that goes on top. All of the geometry in here is what is the successful design that they've had previously. So they're able to carry on while producing this can in a more efficient and sustainable way.
Wow. That's great. I love, what I love too, something that you said, I love when you find a solution and then people realize, oh, we can apply that to something else.
Right. Yes. Yeah. Absolutely. Yeah.
All right. How about servo actuation for control and precision?
So servo controls is something we've been working with for 10 plus years now. We've used it primarily for the unscrewing function, and we do it a lot of different ways. We could use a linear servo to push a rack and pinion device like a traditional unscrewing mold, or in some cases for clean rooms, we will use belts and pulleys driven by the servo, and we leave out the racks and all the grease that comes with that. The other main function is for mold closing on flip top molds. Okay. And then some of the more recent projects, we've had separate servos that will do the closing and then with independent control, the ejector plate actuation. And this actually works very well sometimes because it can be challenging to close up all of the caps in a high cavitation flip top mold. where we have precise control of both those functions, and it's independent. We can play with the relative timing and position of the two functions to give you the best possible closing solution in a big flip top mold.
It's always so awesome to watch.
Yeah, it's exciting, and those systems are getting bigger and bigger. Last year, we had a 2x48 flip top mold running with the type of servo control I just described, running in a 1,200-ton machine here at StackTeck, and it's just a monster. It's a great thing to watch and
It
see
is.
all of that happening with such great precision. So many things happening all at the same time.
That's what mold making is all about. What you just
Yes.
said there and what you could show is what you wish every kid could just be immersed in, and to realize how much science and technology and thinking and fun, right, and creativity goes into making that happen. I mean,
Absolutely.
that's it. All right.
Absolutely.
But I digress. Okay. Number 4, how about fast track, which I know is automated mold design and manufacturing for single face, right, and stack molds.
You just said it really in a nutshell. So we now have for certain types of parts, and especially for thin wall open-headed containers and lids that are round, we can take the models of those parts as inputs to a computer program. We hit the start button, and the computer designs the mold for cavitations up to 2x16, which is really exciting because we normally will spend 4 weeks or more in the design phase of a custom mold, and now we can do it in under 24 hours. Do the work for us.
That's huge.
Right.
That's huge.
And then at the tail end of that, in addition to that, as in that automated design are standards that enable us to use standard fixtures and standard materials that we have in our facility, and that speeds up everything after the release of the design as well. And so we're able to build molds in times that we were never capable of before.
Wow. So you've gone beyond design and streamlined that whole upfront process there.
Right. Yeah, that's what fast track is to us.
Yeah. Okay. All right. How about trim lightweighting technology?
Yeah, so trim is a technology that started a little bit slow. I would say the first production mold we built was in 2013, and our first development mold went back to 2009. It now is definitely gaining momentum. The last summary I saw a few months ago of all the production molds we have built, those trim panels on those parts now save 4.5 million pounds of resin per year, which is a phenomenal sustainability story.
Yes.
And as we go on, we're doing a wider and wider range of applications. Initially, it was specialty items like a deli style environment where the containers are just handled by hand. We now have done some ice cream containers. We've done deli containers. We've done round. We've done rectangular. So the range of applications we've now done, for the ones that we can talk about, enables us to let customers feel more comfortable and to get more of an impression of how it's going to work on their product. And that's why I believe we're seeing a wider adoption of it.
Yeah, that makes sense. Okay, now I know you want to talk about the PET preform solutions. I know my colleague Jackie Dalzell was out to visit you not too long ago and was all excited when she came back about this. So let's talk about StackTeck's patented the PiCool technology for post-mold cooling that addresses challenges with uniformity and the degree of cooling. And I know, I think on the site, I know it says that the PiCool improves cycle time and quality and reduces energy consumption and scrap, right? But why don't you explain this technology and what it means for the whole preform market?
Okay, absolutely. So I'll start just by pointing out that we're actually new to the PET preform mold industry as a supplier. We started in early 2019, actually at the same time we started the automation initiative. And it's a natural for us because it's a high cavitation mold for a packaging application that runs a fast cycle time. That's the kind of thing we do and we've been doing for over 50 years. And, in addition to what you just said, we also have technology advances to offer in the hot roller and the cold half, but I'll put that aside for a minute.
Okay.
Post-mold cooling, state-of-the-art preform systems use a multi-position takeout plate to go into the mold, take out the hot parts from the cores, come outboard, and typically that takeout plate will carry 3 or 4 shots of parts for multiple cycles before releasing them for post-mold cooling. And an advancement that came to the industry perhaps 20 years ago, a little more, was to blow air inside the preforms to cool from the inside as well. PiCool was patented in 2018, and we are using that technology to not just blow air inside the preform while it's being chilled on the outside by the cooling plate, but we also are using guidance to the air to make it go in a spiral motion around the inside of the preform, which gives you more consistent cooling around the perimeter of the preform. And we can show, have data to show how much more consistent the temperature of the preform is when the cooling is done in a spiral fashion. It also speeds up the cooling, which is a great story, because depending on what the preform is, we'll be in the range of between 5 and 15% faster on cycle time when we introduce the spiral path rather than a straight path, which is just, for these systems cost millions of dollars. So
exactly.
Up by 10%, give or take a couple of percent, is something that opens our customers' eyes.
We're going to need video of that, because I think I saw it stated that it's like a tornado style, right?
Right. Yes.
When you said the spiral.
Yes. Yeah.
Pretty cool.
We got lots of video.
Okay. Last but not least, sustainability remains it's a very hot topic. And what I notice is across manufacturing, everybody defines that and approaches that differently. So I know StackTeck has several technologies that address sustainability. Can you talk a little bit about those?
Sure, absolutely. I mean, we have a long list of them in our brochure, but I'll pick on a couple.
Okay.
One is just the design for reusability in our molds. Our mold frames are made of stainless steel. They will quite literally last forever as long as you take care of them and replace some of the wear components in them. And we see this particularly well used when we are building our molds with a quick product change capability, where typically the frame and the hot runner stay in the machine all the time, and you're just doing quick change modules to go from product to product. And the frames and the module plates being made of stainless steel are absolutely reusable. And we see many customers doing that, where all they need to buy going from project to project is the molding surface components that are specific to the plastic part that they are molding. But the frame itself lasts forever, and that's a very sustainable answer. Moving to the plastic side, for many decades, we have built molds for horticultural applications where customers are using 100% recycled material and have been doing that for a long time. And so we have a lot of experience helping them, because it seems like each one has a different recipe and a different approach to where do they get, where is the recycled material coming from? How do they process it? And what is the variability in the properties of the recycled material, both with respect to how does it behave? Sometimes it's like a 30 melt polypropylene today, but then it's more like a 10 melt tomorrow. And a well-known thing is, and I think it's pretty much universal, there's a degree of contamination in any recycling stream. And so something we have learned a long time ago, and we find ourselves, as our customers are embracing recycled materials on an ongoing basis more and more, the things that we have done in the past, where, I mean, we custom design everything, but we make our hot runners have always been built to be very accessible. If you have contamination in a hot runner, it's typically going to get caught behind the tip. And we have a great design for splitting plates open in the press, accessing those tips, taking them out, cleaning them out, putting them back in very short order. You may have had a block drop or two, but you can be back in full production very quickly with our designs. And it's because we know that, because we know at the beginning of the project the questions to ask about a recycled material. Okay, how high might the melt index be? How low might the melt index be? What's the nature of the contamination? What's the size of it? What should we do in the design of the hot runner that the contaminants are going through to make sure they're not catching at points that are really going to slow you down, where you might have to go into a more involved cleaning of that manifold.
That's a real education process with the customer, isn't it?
Absolutely. Mm-hmm. Yeah.
How about you got to talk a little bit about this impact initiative, and what is that exactly, and how are employees involved in this? Right.
So great question. We formed the impact committee with a group of employees from all areas of the business, and we asked ourselves, okay, what is it we're going to do? And it's a very broad initiative. It affects I have no way to cover everything, but I'm just going to talk about how it has impacted employees, and just in terms of the things that we handle every day. You can't walk very far at StackTeck without seeing an impact board where we have a location and we have 3 separate streams in terms of things that we're disposing of. And so not only are there 3 streams to put something into, but there's a whole board about that starts with impact and then gives you a detailed description of, okay, here's the 3 streams, and here's a list of examples that go into stream number 1, 2, and 3. And you know, there's one within 20 meters of my office door right here, and you know, in each office area and throughout our entire manufacturing facility, we put all these things in. And I'll tell you, employees are really pleased to see that we've done something and that it's been clearly communicated. They know what to do. They know what's expected, and it's really just as simple to, you know, take a quick look and put it in the right place rather than just dropping it into, you know, a single spot where you know it's probably going to landfill.
Exactly.
Yeah.
So what you've done is made it easy.
Absolutely. Yeah.
And yeah,
that's what it's all about.
it's all about communication. Well, okay, Jordan, that was a lot. You said a lot very succinctly and clearly. I think everybody listening has a much clearer picture of who StackTeck is and what they've got going on. So thank you for your time.
Thank you for the opportunity, Christina. It's a pleasure.
And for everybody watching, remember, for everything mold making, visit moldmakingtechnology.com. Stay informed and stay inspired.